Hey there, and welcome. You ever feel like your life is just one giant puzzle? Well, today we're going to dive into a fascinating piece of that puzzle that's hiding in plain sight, the challenge of finding the perfect match. I mean, really think about it. It doesn't matter if it's a tiny decision or some massive logistical nightmare. We are always facing this fundamental question. Out of all the possible combinations, how on earth do you find the single best one? And this isn't some abstract philosophical thing. Nope. It's happening all around us, every single day. Who's the absolute best person for this project? What's the most efficient way to schedule shifts this week? Which players are going to create the strongest possible team? These are all matching problems. And you know what? This whole idea of finding the perfect match is so important that it actually has its own name, and it's a huge deal in the world of mathematics and optimization. That's right. This everyday challenge is a famous type of problem called combinatorial optimization. I know, that sounds super complicated, but it's really just a fancy way of saying you're trying to find the best possible choice from a massive number of options. So let's break down what that really means. So what does this problem actually look like when you get down to the nitty-gritty? Well, in the world of optimization, it has a very specific, very clear definition. Let's break that down. In simple terms, it's all about making perfect one-to-one pairings. You've got a bunch of things to assign and a bunch of spots for them to go. The rule is each thing gets exactly one spot, and the goal is to make all those pairings in a way that is, overall, the best. Maybe that's the cheapest, the fastest, or the most profitable. It's all about total optimization. And this simple framework is honestly the key to everything. Every single one of these puzzles, no matter how complicated it seems, boils down to these three parts. First, you've got your objects, the things you need to assign, like a to-do list of tasks. Then you have your resources, the things that will get the assignment, like the machines available on the factory floor. And finally, the big one, the objective. What's the actual goal? What are you trying to achieve? Maybe it's to minimize the total production cost. It's this structure that makes the whole thing solvable. Okay, enough with the theory. Let's see how this framework actually gets put to work on real, concrete puzzles that companies and organizations are solving every single day. And this is where you really see how powerful it is. In a factory, it's all about matching tasks to machines to keep those costs way down. In an office, it could be scheduling training sessions so no trainers are double booked. Or think about a logistics company, right? Assigning 6 trucks to 6 brand new jobs in a way that burns the absolute least amount of fuel. The stakes here are totally real. We're talking time, money, and resources. So, with all these moving parts, how in the world do you solve these puzzles without just guessing? Well, it turns out there's this surprisingly elegant and incredibly powerful tool designed for this exact job. Let me introduce you to the Hungarian method. It's a specialized algorithm that is just fantastic at cutting through all the noise and finding that one single best solution. It's pretty much the hero of our story today. And its biggest superpower? Speed. When you look at the research, it just blows other methods out of the water because it takes so few steps, or iterations as they're called, to guarantee the perfect answer. So it's not just fast, it's incredibly reliable. Okay, so how does this thing actually work? It kind of sounds like magic, right? We're going to walk through the core logic behind it. Now, don't worry, we're not going to drown in heavy math here. We're just going to focus on the brilliant strategy it uses to crack the puzzle. So at its heart, the method follows this really clever 5-step logic. First, it simplifies the problem. It creates what's called a cost matrix. You can think of it like a big spreadsheet of all the costs. And then it just reduces all the numbers. It's like creating a map that highlights the absolute cheapest routes. Second, it finds an initial match, taking a first stab by pairing things up along those super obvious low-cost paths. Third, it checks for optimality. It asks, okay, is this really the best we can do? Does every item have its perfect partner? If the answer is no, and this is the genius part, it moves to step 4. It improves the solution. It has a systematic way of tweaking the cost map to uncover even better matches you couldn't see before. And finally, step 5, it just repeats that improvement cycle until, bam, the optimal, unbeatable solution is found. And that's really the million-dollar question, isn't it? I mean, it's pretty easy to find a solution, but how do you guarantee you found the solution? What happens when that first attempt just isn't quite good enough? This is where the Hungarian method truly shines. It doesn't just give up and say, well, I tried. No way. It has this built-in improvement engine. It methodically adjusts the numbers, revealing better and better assignments with each pass, until it finally lands on the one combination that is mathematically proven to be the absolute best choice. What's really cool is how flexible this method is, too. So the standard goal is usually minimization, finding the lowest cost. But what if you want to do the opposite and maximize profit? Simple. You just convert the profits to negative numbers and run the exact same process. Or what if you have more trucks than jobs? That's what's called an unbalanced problem. The method just adds some dummy jobs to make everything line up and then solves it perfectly. It's designed to handle these little curveballs. All right, let's zoom back out and look at the big picture. Because what we've just uncovered isn't some niche algorithm just for mathematicians. It's a way of thinking about efficiency that applies to pretty much everything. Because at the end of the day, it doesn't matter if you have thousands or even millions of possible combinations. The goal is always to find that one, the single best combination that gets the job done. And that's the big takeaway here. The assignment problem and brilliant tools like the Hungarian algorithm are all about making smarter decisions. We live in a world with limited time, limited money, limited resources, right? Well, this is a formal strategy for finding the absolute best way forward. So the next time you're trying to schedule a big project, plan a trip, or even just organize your week, remember this. Buried somewhere in all those choices, there is an optimal solution waiting to be found. And now you know the secret isn't just making a lucky guess. It's having a system.